Assalamualaikum warahmatullahi wabarakatuh. My name is FIKRI bin ISMAIL. So I'll be representing my group for the introduction of our topic. So our topic will be going to talk about direct volume rendering for recasting. Okay, so these are our group members. On the left is me. Then we have Pingi, IRDINA, and also AQILAH. Okay, so for the contents of our presentation, we'll be going to do the introduction, methods, comparison, example of implementation, and also the references. Okay, so for the introduction, what is recasting? So recasting is a computer graphics and computational geometry rendering technique that capable of transforming a limited form of data into a three-dimensional projection with the help of tracing rays from the viewpoint into the viewing volume. So recasting is fast as only a single computation is needed for every vertical line of the screen.
Assalamualaikum, my name is NURUL BINTI AHMAD, and now I would like to continue the presentation of the method in implementing recasting in volume visualization. So this slide is contained about the components of a recasting system. The first one, in recasting system, we must have the memory system that will contain the dataset and responsible for supplying computational units. And the second one, there will be ray path calculation to calculate the ray voxel intersection in order to determine the voxels that are penetrated by a given ray. And the next one, there will be interpolation. This interpolation is involved to estimate the value at a resample location. And then there also will be gradient estimation. Basically, this fourth component here is to determine the gradients in approximating surface normal for classification and shading. Therefore, the next one will be the classification in order to map the sample value to a color and also opacity. By using this classification, there also will be a shading in this component. It will fully utilize the gradient and classification to compute the color. And then the final component will be the composition that will use the shaded color values and also the opacity in order to compute the final pixel color to display. Alright, so the next one. From the components, we can simply determine the basic steps of volume recasting here. There are 4 steps involved, which is the first one is recasting itself that will cast a ray from the view plane here. And the next one will be sampling, which is from the view plane, we can determine the intersection volume along the path of the ray will be sampled. And the next one, there will be shading to compute a color for each voxel based on a shading model here. We can see that the intersection volume will be shaded to determine to compute a color value. And the last one, as I said earlier in the last slide, which is compositing to compute the final pixel color on the view plane.
Okay, good morning, doctor. So now my name is Pingi. So I want to continue explain the method of the volume rendering using recasting. So this is the theory part. So this diagram will be called a Brin-Khadijah model. So this model will be so a ray that come from the eye will be penetrate into the volume that contain a density. So the light source that will penetrate a illumination and then to the volume that contain the density and reach the point between the ray around the ray inside the volume. So the intensity scattered around the ray to the eye depend on this value. So reflection function of P and the local density D. So the bright particle will scatter less light in the eye direction than a number dimmer particle. So the middle one will be formed lighter and the side one will be formed a darker dimmer particle. So this is a basic theory. So from this part we see the equation. So the parameterized density function along the ray will be using the D. D will be have the XYZ, the XYZ distance, the point XYZ in the 3D Cartesian. So equal to dt. T represent the distance. Then the illumination from the sources that will be the source will be called the light source will be represented by IT, and the T represent the distance. The illumination scattered along R from the point distance T along the ray. So we'll be see the point distance T along the ray. This is the ray. So this is the point distance. So the illumination will be penetrating into the volume of the density will be using the IT times with dt times with P. P is a function. Inside will be cos antisect. This where the antisect is the angle will be calculate the angle between the R and L, the intersection between R and L, and this part will be calculated the angle. This part is the angle, will be calculating the light vector from the point of interest. This is the point of interest. So this is the calculation of the illumination scatter along R from the point distance. Between the point distance T will be calculate the angle between the ray and also the L. The L will be called the light vector from the light source, and this will be calculated the function. So this is the part of it. So I will pass it to my next teammate. Thank you.
My name is NURUL binti FADZIL, and I will continue the presentation on the comparison between ray tracing and also ray casting. So basically, ray tracing, it collects information of lighting and also shading in 3D object space. Compared to ray casting, it collects information on the volume data. So the goal of ray tracing is to compute realistic scene or image, because it will collect information of the lighting and on the surface. Compared to ray casting, it is used to visualize detail and features inside a volume 3D. So for ray casting, it is mostly used in computer graphics, games, and also movies. Ray casting is used in volume visualization, such as medical visualization. So for ray tracing, it uses arbitrary number of rays for each pixels. Compared to ray casting, it only one ray per pixel. So after this, I will explain about the rays. Okay, next is for ray tracing, the input of the scenes is actually the surface of the object. Compared to ray casting, it's actually the volume data of the object. Okay, so next, here is the comparison between ray tracing and also ray casting. So for ray tracing, basically the ray will enter the plane, the screen, and hit the object. After the ray hit the object, the ray will be reflected back through the space. Compared to ray casting, if the ray touches the object, it will continue to into and penetrate into the object to get the volume data of the 3D object.
This one, we're going to have the example of implementation for ray casting. So the first one is being used in the CT scan machine, which for medical purposes, and also included in the X-ray machine as well. Okay, and then for weather forecasting, for the tornado pressure radar. And the last one is for chemistry purpose, is for the molecular data measuring. Next one is the references. Okay, that's all from us. Thank you.